One more thing I want to talk about with this is materials at standard conditions. Okay, so gas at standard conditions. The gas is at standard conditions. The standard conditions for gas are a little bit different from thermodynamics. If you remember from thermodynamics, was 1 atmosphere of pressure at 25 degrees Celsius. Here, the temperature is going to be equal to 0 degrees Celsius or 273.15 Kelvin. Okay, so that's the temperature. Pressure is still going to be 1 atmosphere. Okay, so those are at standard conditions. So if I look at any standard conditions and I start looking at the gas law, so here's gas law, right? If I have 1 mole of material, okay, so if N is equal to 1 mole, then 1 times these is going to cancel out. So PV is equal to RT, because this was 1, right? Okay, so I have 1 mole, pressure and volume is equal to the gas constant times the temperature. Now at standard conditions, okay, and notice that this is for any gas, 1 mole, right? These are independent of the gas itself. So for any gas, for any material that we have, if I have 1 mole of it, PV is equal to RT. Okay? What this means is that at standard conditions, I can now that my standard conditions are 1 atmosphere, I forgot the T there, 1 atmosphere, okay, and 273.15 Kelvin. Okay, so P is equal to, and I don't want to multiply it by 0, because if I multiply it by 0, everything becomes 0, and that's a problem. So I'll rearrange this so I get volume. So volume now is equal to RT over P. Okay. So now I get 0.08206. Okay. You remember the units for that? If you forget, okay, they got to be there, right? Okay. So R, if we rearrange that, PV over NT is equal to R. That tells you what the units are. Atmosphere times liters times number of moles over temperature. I just realized it's kind of hard to see in the video. I'll switch to a different color. All right, so let me rewrite that so you can see it a little bit better. Is that a little bit better contrast? A little bit better. NT is equal to R. Okay, so the gas law, the units are going to be atmospheres times liters over moles times temperature. Okay, so atmosphere times liters, all this over moles times temperature. Okay, at standard conditions, okay, little circle there, that means that this is going to be times 273.15. That's Kelvin. So I'm using Kelvins here because Kelvin and Celsius are interchangeable, right? And my pressure is going to be 1 atmosphere of pressure. So my atmospheres cancel out, my Kelvins cancel out, okay? My moles were up here. Those disappear because I had N over here is equal to 1, so I still had a moles term. The moles cancel out. So now I do the math associated with this, and what it comes out to is that the volume at standard conditions for a gas is going to be equal to 22.1 liters for any gas. All right? So you can be using xenon, you can be using nitrogen gas, you can use gaseous ether, it doesn't matter. So long as it's a gas, it's at standard conditions, 0 degrees Celsius, 1 atmosphere, the volume of it is going to be 22.1 liters. So long as we say it's at standard conditions. That's an important thing to remember. Important thing to memorize for exams because it usually pops up on exams. Okay?